All right, hey guys, how's it going? We're going to be going over a quick lesson, specifically 8.1, around angles of polygons. So I am assigning this to you as the 10th. I will be checking this on the 12th. Let's go ahead and write that. So we're going to write 8.1 angles of a polygon. Cool. This is worth 10 points. All right, so I'm going to go ahead and jump ahead. And a lot of this lesson at first is going to cover some things that are things we've covered in the past unit. For example, if we start looking at number 1 here, it says solve for the missing angles. Find the third missing angle using triangle sum theorem. And so remember that when they talk about triangle sum theorem, this will specifically refers to interior angles of triangles. Always, always, always add up to 180. And so I'll let you work through these problems. If you forgot, one thing I do want to change actually that I didn't like. This angle right here reads as 84 degrees. Can you please change that to 26 degrees instead? And then do what you would normally do with this problem. So you'd set it up. All equal to 180. And so that first problem is mainly review. I'll let you work through that. And then this is where there's some new stuff. So looking specifically at number 2, we're given a shape that we're not used to looking at yet, which is a pentagon. And just a reminder, so pentagon has 5 sides. And it's important to keep track of the sides and the shapes that you're going to be seeing for the entirety of this lesson, the pages that you're going to work on. And so we could read everything here. It says the pentagon at right has been dissected or broken up into 3 triangles. And so we can look at this entire pentagon and see it's cut into this triangle, this one right here, as well as the one down there. And so then it says, use the 3 triangles to determine the sum of interior angles of a pentagon. And so this is what's new here. The sum of interior angles, not specifically of a pentagon, but we're going to talk about mainly polygons is what you'll be looking at here a lot of the time. All right, so what you should remember when looking at each one of these, right, is each triangle has a value of 180 degrees, right? Talking about the interior angles. 3 triangles, 180 degrees each. And so if you want the entire total, what you would do is you'd take 180 degrees and you'd multiply it by 3. And would that not give you the total for the pentagon? So you go through that. We're going to take 180 times 3. And the interior, the entirety, right, of those angles is 540 degrees. And so remember that when we're being asked for the sum of interior angles, all answers, keep them in degrees. And I'm going to move forward now, right? We're going to go to number 3. And it says, use the same strategy in number 1 to determine the sum of the measures of interior angles of the following polygons. Okay, and so polygons, if you don't remember, polygons are figures. We usually call them shapes, but they're figures that have at least 3 straight sides and angles. It's typically going to be like 5 or more, but we started out with triangles first, and so now we're talking about different ones. And so the same strategy, we'll jump back to that, but what I want to do first is label what's in front of us so we can keep track. So the first shape right here is going to be your hexagon, and I'm just going to say it has 6 sides, right? And that's already a given to me. The one on its right is a heptagon, 7 sides. It's a little messy, but you know what I'm writing. And then on the far right is an octagon, like MMA. And that's going to give you 8 sides right there. All right, sweet. So I just wanted to label it because I don't want to have to keep looking back up here and trying to remember things. It's just nice to keep it labeled. And so now back to here. Same strategy. What strategy? Earlier, we were looking at this pentagon, and the strategy they did was break it up into triangles. And so notice that you have these vertices all around, and when they drew them, they connected from one to the other, right? From here to here, connected in order to make those triangles. And so we'll try it first with this hexagon. And so, right, I have all these vertices right here. And you should have the amount of sides basically as well, right? And so I want to go from one to the other. What you don't want to do is take one and just like go across here, which technically actually, you know, it wouldn't work out because then what do you do with these, right? It's a little tricky. But I'm gonna draw these out. It's nice if I do one right here. Right, there's a triangle. It's nice if I make another one right here. And then another one here. And then notice that this line I'm drawing right now, when I drew it, it actually created it actually created one triangle here and here as well. And so now, using the strategy, you must ask yourself, how many triangles do I see? We see 1, 2, 3, 4 triangles. And then once again, the value of each one we know is always 180. And so this time I have 4 triangles. I'm like, okay, cool. So if I want the sum, right, all of them added up, the sum of the interior angles of this entire hexagon, I must take 180 and multiply it by the amount of triangles that I see or I have. And in this case, it's 4. So 180 times 4 gives me 720 degrees. I will go ahead and let you do the same for heptagon and for octagon. Like I said, just make sure you're drawing some nice triangles in there, right? Count them up, multiply them by 180 because you're using that strategy, and so forth. So down here, they give you a chart, and you will have to fill this out. We'll do it together, but there's something that you end up noticing, okay? And maybe I'll just go ahead, maybe even with maybe the octagon problem. So I'll actually finish this one here, even though I wasn't going to. Okay, cool. So this one has 1, 2, 3, 4, 5, 6 triangles this time. 180 times 6. That gives me 1,080 degrees for the sum of the interior angles. There is a pattern that you should start noticing. So when I had 6 sides over here, so looking at the hexagon, when I had 6 sides, there were 4 triangles. When I had 8 sides, there were 6 triangles. And if I look up even higher up here, when we did the pentagon problem, when I had 5, I had 3. And so looking even at this chart here, right? If you're given 3, there's only 1. That's a triangle. If you're given a square or something that's 4 sides, it is 2. Every single time, there is a subtraction of 2 going on. Every single time. So you can imagine this is 4 when you subtract 2. This is 5. And what we're talking about is triangles, okay? That's how many triangles. 6, 7, 8. Once again, this is the amount of sides you are given in a shape. The triangles that show up inside are always minus 2. Okay, always minus 2, minus 2, minus 2. And just to remind myself, triangles 180 degrees. All right, and so I'm going to just do the rest of this, and I'm going to fill out all of that. So this would be 540, 720, 900. I'll let you fill out the rest of those. And it's just to show you that there's something going on there. And so this bottom question now says, find the sum of interior angles of a 100-sided polygon. So we're thinking of a really big figure that has 100 sides. It does not help to do the strategy of drawing that whole thing out and drawing a bunch of triangles in there if we know that every single time we are given a side, we know how many triangles there are if we just subtract 2. So if I am given 100 sides, I'm going to take 100. I'm going to subtract 2, and that's going to tell me how many triangles I have. If I drew them all out, right, we're going to have 98 triangles. And if I have 98 triangles, and I know each one is 180 degrees, then I'm going to multiply this by 180, and that will give me the sum of interior angles of the 100-sided polygon. So I'll do that. 98 times 100, that's going to be 9,800 degrees. There's something we didn't talk about. Second sentence, third sentence is explain your process. I kind of explained it out loud, right? We always subtract by 2, and then we multiply by the degree measurement of a triangle. And so it says, write an algebraic expression that can be used to determine the sum of interior angles of an n-gon. And so when they say an n-gon, right, that just means, n is for how many sides, right? Number of sides. I should have mentioned that up here. So when you have the number of sides, we can always use a little, I don't know, a variable. We could just call it n. So we'll say n is how many sides I give you. For example, what is n for this shape? It is 3 because it's a 3-sided shape, right? That's like the triangle. What is n in this column? N is 4, 5, 6. And so in this example, n was 100. And so when they ask for an algebraic problem, this is the whole new formula that we're looking at for polygons. And so officially, you can say, if you are looking for the sum of interior angles, I guess, of a polygon, I'll just put that in parentheses, but this is the sum of interior angles formula. The formula is always going to be n, as in how many sides you are given, minus 2, as we noticed the pattern, and then always multiplied by 180 degrees, which comes from the triangles that exist within these polygons. And so maybe you just want to add a note for yourself. You don't have to. This is number of sides. And that special formula is this one that you'll use every single time you are asked to find the sum of interior angles. Okay, cool. So that's the notes for that. You have some problems to work on here on page 2. I'll let you go through that. What I do still want to get to is here on page 4. And so page 4 looks like this. And there's something that we need to conclude down here. And so we can do that in this video. And notice that they're no longer talking about interior angles on this page. They're talking about the exterior. And remember, exterior just means angles that exist on the outside, the exterior of the shape. So when they refer to the exterior angles, they are talking about this angle right here, this angle right here, and this one along as well. And so we're being asked, what are we being asked? Let's see. And they say exterior angles are always supplementary to their adjacent interior angle. We know adjacent means next to. They're saying that this angle plus the 61, they're always supplementary. Supplementary, that's an old word for us. That means it adds up to 180 degrees. And so if I'm supposed to find the exterior angles and I want to start with this one, I need to figure out what this angle is. I could just take 180 and subtract 61. Use a different color though. So this is going to give me 119 The angle above 180 minus 79 is going to give me 101 for that exterior angle. And then for that 40 degrees, 180 minus 40, we have 140 degrees. And so I found my exterior angles, but they said, let's talk about the sum of the exterior angles. And so sum meaning I want to add them up. So let's go ahead and look at that. We're going to take 119, 101, and 140, and we're going to add them all together. So it looks like 119, 101, and 140. They add up to 360 degrees. How nice, right? And so let's test this out one more time. I'll try it with, let's try with this one. Okay, let's try this out. And so following the same process, they're supplementary. I'm gonna start with that one that says 124 on the top right. So 180 minus 124. So 56 degrees is right there. I'm gonna go to the 76. 104, just finding exterior angles. Oh man, there we go. 91, 109, and then that looks like that's it, right? That's all the exterior angles I could find. All right, cool. So I'm gonna take these four. All right, we have 4 exterior angles this time because we have a 4-sided polygon. And I'm going to add them up and see what happens. So 109 plus 56 plus 104 plus 91. Guess what? The sum of the exterior angles is also 360 degrees. And so the conclusion you should come to, I'll let you figure these out, right? Give me the values that are missing on the exteriors and give me the sums. But most likely than not, right, the conclusion here is the sum of exterior angles, and I guess I'll fully write it out. The sum of exterior angles of any, right, because this is any polygon. If you keep testing this out, any polygon, the sum of exterior, yeah, I already said this, so I'm not going to say adds up to again. The sum of exterior angles of any polygon is always, that's not a Y, always 360 degrees. Okay, and that is what we discover. So you can write that, focus on finishing up the rest of these problems. It looks like even these bottom problems are just asking you to take what you have, solve for x, knowing that the exterior angles make a circle. They make 360 degrees. I could kind of show you how the setup for this one might look, for example. So that means I would take x plus 2x plus 95 plus 85 and set them equal to 360 because that's what they should add up to. And then you could do all that work. Yeah, you're going to be doing pages, finish the rest that I didn't finish on page 1. Page 1, page 2, 3, 4, and 5. I will be checking for this on Wednesday. Just make sure that's all done. If you have questions in the meantime, just reach out to me. All right, I hope this video was helpful.